In this lecture, we will be writing a very simple program to generate output that the user of your program will be able to see. This will give us a foundation upon which we will build much more complex user interaction in future lectures. So here on Visual Studio 2019, I'm going to click Create a New Project. Make sure that you have C++ set as the language and that you select Empty Project. And then click Next. Here I'm going to ensure that the name of the project is Hello World. Notice there's no space in the name. Although I could put a space in the name of the project, it's a common convention not to do so. A convention is just something that is typically done by professionals. Then I will click Create. So with this new project, over here under Source Files, I'm going to right-click here and go to Add, and then New Item. And then I'm going to add my CPP file right here. You can choose what name to give it. I typically change it to main.cpp, although you could leave it as source.cpp, and that would be fine. Then I'll click Add. The source code is just the C++ that we write. The code we're about to write might look very foreign if you're new to programming. Don't worry at all, though, because you'll get the hang of it once you've been doing it for a while. We will write the main function, which acts as the entry point to our application. The entry point is where the program starts. So here's our basic code, which I'll explain in just a moment. Let me explain a little more about this code. You'll notice the #include Iostream, or hashtag if you're from the Twitter generation, that I've added. This is called an include preprocessor directive, which is essentially just instructions for a part of the C++ system called the preprocessor. It tells it to include the contents of a library, in this case called Iostream, which we'll talk about in just a moment. The preprocessor does any work that is needed before another part of the C++ system called the compiler converts our source code written in C++ to machine code that the computer can understand so that it can run our program. Computers don't understand languages like C++ or Java or other programming languages directly, so this code often has to be converted into machine code so that the computer can understand it, and that is what the compiler is responsible for. Another term that is very important to our discussion is library, which is a collection of various objects, functions, templates, and other things that help us get our jobs done as programmers. Don't worry if you don't know what objects, functions, or templates are. We will learn about them much more thoroughly later in the course. For now, just know that these are things that help us write code that do rather complicated tasks with very little effort on our part, because much of the complex coding has been done for us and provided for us in the form of these libraries. So specifically, the library that we've included up here is Iostream. The I/O in Iostream stands for Input-Output Stream. It allows us to interact with the user, putting information to this thing called the console, which we'll talk about in just a bit. It also allows us to take in input from the user from devices such as the keyboard. So back to our code as a whole. If we were to run this code, it wouldn't do much of anything, or at least you wouldn't see it do much of anything. That's because it just loads the main function, which is the entry point of the application, and runs it, and then the main function returns the value 0, which is just a signal to the system that nothing went wrong. However, if we want to see something happen, we need to have some sort of information displayed to us when we run the program. To do that, we will learn about two new pieces of syntax, which again means grammar rules of the language. So, I will write the cout object, but I first have to prepend it with this thing called std and then : which is the scope resolution operator. This says that the cout object belongs in this thing called the standard namespace. A namespace really is just, like the name suggests, a space where different names live, and is to keep conflict from occurring. So someone might have one namespace and they can have their own cout object, and the standard namespace has its own. So that just means that if you prepend it, you're saying, I'm using the one that I'm talking about from the standard namespace. Now, hopefully we won't have naming conflicts very often, but that is what we have to do in C++ in order for it to work properly. So the cout stands for character output, or is sometimes just called console output. The console is the default place that the cout object sends data to. The stream insertion operator, which looks like two less than signs, works with objects like cout to send character data to the console. Notice that these less than signs are actually really just arrows, and they're pointing toward the cout object name. This is the direction of the flow of the data. The data flows from the right of the stream insertion operator and into the console ultimately. Note also that you can use the stream insertion operator over and over again, even in the same line, to separate various variables and literals, which we'll see right now. So right here I'm writing this hello world, and then I have, again, the standard namespace indicated with the scope resolution operator, and a variable called endl. This right here, hello world, and the double quotes, is called a literal. Specifically, this is called a literal constant. And to be even more specific, this is called a string literal constant. We will cover strings much more thoroughly later in the course, but for right now you can think of it as just a string of characters, or string of these letters and spaces and things. So that's what we have right here. The stream insertion operator separates the cout object from this string literal right here, and then also from the endl object right at the bottom. So let's run this without debugging and see what happens. So to run this, I will go to debug, start without debugging, and now we will finally meet this console I keep talking about. So this is the console. It is text-based. It doesn't generally take mouse input. It's mostly for keyboard input and, of course, console output. So we see our program has generated hello world, and then a new line, and then this path right here. And it does say exited with code 0 at the end of this. So that means that it succeeded. And then there's press any key to close this window. So the last two lines are actually generated by Visual Studio. The only output that's really generated by our program is hello world and then the new line right here. So that's what the endl does, is generates a new line and puts that into the output stream. Pretty exciting. This is obviously just the first step on a long journey. Note that we have to keep writing this std followed by 2 colons before the cout and the endl. That can get a little bit tedious and redundant after a while. So there is actually a shortcut that we can use heavily throughout this course that will keep us from having to write this. So at the very top, I can tell it what is the default namespace, or what is one of the namespaces that I'm using. And in this case, it's using namespace standard. If I do that, then I don't have to write standard followed by the scope resolution operator. So let's run it again just to make sure we didn't break anything. I'm going to go again to debug. Start without debugging. It will automatically call the compiler and convert our code into machine code, and then it will run the application. So here's our console again. And again, we get hello world, followed by a new line generated by the endl, and then the data that's printed out from Visual Studio. Brilliant! We have our output again. It does the exact same thing, but the code is much more concise. One last question I'd like to answer is, where does cout come from anyway? And the answer is the Iostream library that you have included at the top. The include directive includes the Iostream library so that we have access to, among other things, the cout variable. Now, before we move on to another lecture, I want to give you a little challenge. I want you to replace the string literal that currently contains hello world with hello followed by a space, and then followed by your name. So in my case, it would print out hello John. So I want you to pause the video, give it a shot, and come back when you've done it, or if you get stuck. Okay, I hope you were able to accomplish that task. Let's do it together so we can make sure that you know how. So I'm going to change this from Hello World to Hello John. And let's run it again. So we're going to go to Debug, start without debugging. It'll build the application, and if there are no errors, it will just run. So it says Hello John now, followed by, again, a new line. I hope you were able to get that to work. If so, nice job. If not, it's not that big of a deal. We will learn as we go along, and you will get much better. So wow, we learned a lot in this lecture. We wrote our first source code in C++, and then compiled and ran the program to see the output that it produced. We learned the basics of the using directive, which makes our lives easier when we want to use constructs such as cout and endl. Being able to communicate with the users of your application is very important, and we just took our first steps in doing so in C++. That's it for this lecture. I'll see you in the next lecture, where we will learn about data types and variables.